Okay, so let's start class today. Last class we have started convolution sum, right? Very important uh, mathematical formula for discrete time system to calculate the response. So what we have discussed, uh, last class for any LTI discrete time system, linear time invariant discrete time system, if the input is given, x of n is our input, impulse response h of n is given, so we can determine the output or the response of the discrete time system by convolution sum formula, which is input input convolution with convolution symbol is asterisk with the impulse response h of n, right? What is the formula for convolution sum? Summation k from minus infinity up to infinity, x of k, which is our input, times h of n minus k. So this is the convolution sum formula we have discussed last week. So we have seen one example, if you remember last week, how to solve this convolution sum formula. It's very important in the SP. It's one of the time domain analysis method for discrete time LTI system, the convolution sum formula. So today we'll see one more example on discrete time convolution sum, and we'll see another very important time domain analysis method for digital systems, which is difference equation. We'll see that also today. But before that, let's see one more example, how to find output of a LTI discrete time system using convolution sum formula. Okay, there are many methods, as I said, to calculate this summation. You can use this definition also. For example, here, to calculate output at time 0, when time is equal to 0, right? When n is equal to 0, what will be the output? Here we are calculating output, right? So at when time n is equal to 0, what will be the output? So use this formula. What is the convolution sum formula? Summation k starts from minus infinity up to infinity, x of k, right? X of k here, times h of n minus k. Now n is how much? N is 0. So substitute n. So it will be 0 minus k. It will be minus k. Right? So this way, by adding x of k multiplied by h of n minus k, what's h of n minus k? So what are the steps here to calculate this summation? Step one, h of k, first the impulse response by folding operation. Step one is folding, right? We have discussed what folding operation is. So folding operation, fold the h of k, it becomes what? H of minus k. Okay, after folding h of k. Then we have h of k and given. The input and impulse response is given. So what we have to do first, fold impulse response h of k to get what? H of minus k. Then what is step 2? Step 2 of calculating convolution sum is multiplication. Multiplication in this case we multiply what? X of k times h of k, h of minus k, sorry. First we have to fold it. What is step 3? Step 3 is summation. After multiplication we take what? Summation. So summation x of k times h of k. These steps you can apply to determine the convolution sum formula. It's time-consuming procedure to apply this definition of convolution sum. The easiest method, as we have discussed, there are so many methods like polynomial multiplication. You'll find this in DSP books, graphical method, and so on. But the easiest method is tabular method. So let's see one more example. How to calculate convolution sum formula to determine the response or output of LTI system when input and impulse response are given. So let's see one example here. Now, as you can see here, input is given, impulse response given. We are asked to calculate the response y of n using tabular method. So let's see how to solve this in tabular method. So as you know, tabular method, you write x of n, sample value of the input, horizontally. In this case, what are the samples? 3, 11, 7. What is the first one? 3, 11, 3, 11, 7. What is the next? 0, minus 1, 4, 2. 0, minus 1, 4, 2. These are samples of the input x of n, right? So we form a table. We form a table here, as you can see. We form table. All samples we write horizontally, that is x of n. Then here we write our impulse response vertical, h of n. It's also given here. What are the samples? 2, 3, 0. So 2, 3, 0, minus 5, 2, 1, right? Minus 5, 2, 1. Am I right? Minus 5 to 1. Okay. So this is our table. Okay. So the next we form the table like this. So y of n, this we write it here. H of n we write it vertically. X of n we write it horizontally. Okay, the form table like this. So let's see the form here. So these values are our input 3, 11, 7, 0, minus 1, 4, 2, which is our input, right? This 3, 4, 11, 7, 0, minus 1, 4, 2 input. This side, h of n, as you can see here, 2, 3, 0, minus 5, 2, 1, which is our impulse response, h of n. Okay. Next, what is the first step? Multiply, right? Multiply 2 with each. This is the first impulse response, multiplied with each input samples. Okay. So how much 2 times 3? 6, right? Multiply 2 times 11, 22 here. 2 times 7, 14 here, right? So multiply this impulse response with each of these inputs. So 2 times 7, 14. 2 times 0, 0 here. 2 times minus 1, minus 2 here. 2 times 4, it will be 8. 2 times 2, it will be 4. Now, first multiply all. Next step, shift one step, okay, skip, jump one step, then again multiply the next sample from impulse response, again multiply this with each input samples. So 3 times 3, 9. But before we multiply, as I said, you have to shift, because in convolution sum formula, when you see convolution sum formula, there is shift operation. Okay, we have to do this shift operation. So that's why we jump by 1, shift, then multiply. 3 times 3, it will be 9. 3 times 11, 33 here. 3 times 7, 21 here. 3 times 0, 0 is here. So multiply 3 times minus 1, minus 3. 3 times 4, 12. And 3 times 2, 6. Next, what is the impulse? 0. Then before you multiply, first case, no shift here. As you can see here, there is no shift. Next multiplication, we shift by 1. Next multiplication, we shift by 2 times. Okay. After shifting 2 times, again multiply the impulse with each input samples. Multiplication. When you see the formula of convolution sum, h is multiplied by x, multiplication. First shift, you see this? This is shift to operation. Then multiply h with x. Then when you multiply shift by 2, then multiply each sample by 0, we get all zeros. Multiplication, any number by 0 is 0. Next, shift by how many times? 3 times. Here you see, no shift, shift by 1, shift by 2, shift by 3. In this case, shift by 4 times. The last one, shift by 5 times. Okay, before you multiply, you have to shift. So after all this multiplication, what is the next step? The next step is summation on the formula. Okay, so when you see here, 2 times 3, we write 6. 2 times 11, 22, right? 2 times 7, 14. 2 times 0, 0. 2 times minus 1, minus 2. Here it is 8. Here it is 4. Next, you jump by 1. Then again multiply 3 times 3, 33. 3 times 1, 11. Sorry, this is 9, right? 3 times 3, 9. 3 times 11, 33. 3 times 7, 21. 3 times 0, 0. 3 times minus 1, minus 3. 3 times 4, 12. And 3 times 2, it will be 6. That is the second step. Next, what you have to do? Jump 2, shift by 2. Again multiply 0 times 3, 0. All zeros, because multiplication by 0 is 0. Okay. Next, shift by how much? 3 times. Then multiply by minus 5. Minus 5 times 3, minus 15, minus 55, and so on, like this. This is how we do it. It's very, very simple method to determine the convolution sum formula. Then what is the last step? Summation. As you can see here, after multiplication, after shifting, we have to add to find what? To find the output. Okay, so when you add here, don't add the input. We add only the results, vertical addition. The first column we have only what? 6. Okay. What is the second part? Here, look, we are not adding 3. These are inputs. These are the results. Next, how many? We have 22 plus 9. Addition, which we get what? 31. These are our outputs. Next, we have 3, 14 plus 33 plus 0, 47. Next, this column 0 plus 21 plus 0 plus minus 15, we get 6. Minus 2 plus 0 plus 0 minus 55, 6, we get minus 15. Okay, so we add vertically in this table. Finally, we get our output y of n. Very simple method to calculate the convolution sum formula. Here, then you have to check how many samples in x of n. 1, 2, the lengths of x of n, the total samples of the input. How much? 1, 2, 3, 4, 5, 6, 7 samples. Right? What is the length of h? Length of impulse response in this case. 1, 2, 3, 4, 5, and 6 samples. So what will be the length of the output? Always length of y output is equal to length of input x of n plus length of h impulse response minus 1. This is a formula always. So how many samples in the input? 7 samples. How many samples in the impulse response? 6. So what will be the length of our output? The summation 7 plus 6 minus 1. Okay, this is always the formula. So how much? 7 plus 6, 13 minus 1. So output will be 12 samples. Let's check. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 samples. Always the output, the length of the output is the summation of the length of the input plus the length of impulse response minus 1. So our output has 12 samples. Okay. Next, you have to know where you put the arrow. Okay, where is the arrow? It's very important to identify the arrow. Arrow indicates here which value at n is equal to 0. The output at n is equal to 0. So how do we know it is this value is at n is equal to 0? To determine that, here the input arrow is here. You see? So how many samples to the left? 1, 2, 3. This case, 3 samples. 3 samples to the left of the arrow, to the left of the arrow. For the input, how many? For the left of the arrow, we have 3 samples, right? For impulse response, this here is the arrow. So how many samples to the left? Only 1 sample. For impulse response, we have only 1 sample, only 1 sample to the left of the arrow. Okay, to the left of the arrow. This is for the impulse response. Now, for the output, how many samples to the left of the arrow? We have to add this. Okay. How many samples to the left of the arrow for input? 3. How many samples to the left of the arrow for impulse response? Only 1. So number of samples to the left of the arrow for output will be the summation of these two. So 3 plus 1, it will be 4. Okay. For output, we have 4. We must have 4 samples to the left of the arrow. To the left of the arrow. This is for our output. Okay. So when you see here, how many samples to the left of the arrow? We count from here. 1, 2, 3, 4. Then we put our arrow. How many samples to the left? 4. Why we put 4 to the left? Because input has 3 samples to the left. Impulse response has 1 sample to the left. The output always must have 4 samples before the arrow. Okay. So we are discussing discrete time systems in time domain. So one important point we have discussed so far is convolution sum formula. As we have discussed, convolution sum formula is very important to determine the response of only a LTI system, no other type, only a linear time variant system. The output can be calculated using convolution sum formula. Now, another very important point I want to discuss with you today is difference equation. Okay, difference equation is very important part in chapter 2 for discrete time systems. Okay, you raised your question. So if you have any question, Saad, you have question?
Yeah.
Okay.
I have a question.
Okay.
In
Yes.
For the question,
Okay.
I need for the how I can know for the how many numbers there are left for the arrow.
Okay. So Can you see the slide?
Yes.
Okay. So for look here, the arrow we put it at minus 51, right? Minus
Right.
51,
Yeah.
which is our output when n is equal to 0. So how do we know it is here or here or here? How do we know? That's your question. So
Yeah.
to determine,
Yeah.
you have to go to your we have to go to our input. This is our input. The arrow is here, right? You see the arrow? The arrow for input is this arrow is here. So how many samples to the left?
3.
3. Okay. For impulse response, here is the arrow, right? So how many samples to the left?
Yes. That's
How,
arrow axis. That's
for
got all.
for input, we have 3 samples to the arrow. How about for impulse response? How many samples to the left?
1.
1. Very good. So add the 2. For input, how many samples?
4.
3. 4. So what you have to do is go to your output after you calculate the output here, y of n. How you have to count 4 samples. 1, 2, 3, 4. Then you put your arrow. To the left of the arrow, how many samples? It must be 4 samples. Why we choose 4?
4.
Why we choose 4? Because for input,
Input
how
and,
many? 3
and out
samples, right?
3.
For impulse response, 1. 3 plus 1, it will be what? It will be
4.
4
4.
samples. Okay, 4 samples. That's why. Is it clear?
Yes.
Okay. Now,
Teach.
yes, another question.
Always access the output.
Yes.
Input. Input and
Ah,
h of n. The
given.
arrow is already access.
Yes.
It's given.
Given always.
Yes. Usually.
Always.
Usually. Yeah. Yes.
Always. Input given.
Yes.
Impulse
Yes. Yes.
response given. Why we need convolution sum to
Yeah,
calculate
and there
what?
are and
Yes.
and
Yes.
there are is access.
Yes.
Yes. Understand.
Okay.
Okay. Teach.
You can do it also by MATLAB.
Yes.
Do you see the MATLAB?
Yes.
Okay. So here, what you have to do, which are
Window.
given are input x is equal to, what are the samples input? 3, 11, 7, 0, minus 1, 4, 2. This is our input, right? Now I am writing my program on the command window. I'm not going the editor window for the time being. What is the other given thing? H. H is equal to impulse response. In this case, how much? 2,
2.
3,
2.
0, minus 5, comma 2, 1, right? This is H. Always input is
Yes.
given, impulse response is given. We have to convolve the two to calculate what? Output. So in MATLAB, what is our output? Y is equal to conv. You write simply CONV
Egg.
x,
X.
H. Very good. Now, when you enter, you will
What?
get the
H.
output. You will get the output. You look here. We get what? Output 6, 31, 47, 6, minus 51, minus 5, 41, up to 2. you can check the answer with the method we have done here using tabular method. You get the same answer, 6, 31 up to 2. Okay, this is how we do it. Any other question?
Teacher,
Yes.
you-
Calculate.
always you use in table, this table,
The easiest method.
columns and rows. When you calculate it in convolution, you use it in a table.
Tabular method. Why we choose tabular method? Because it is what? Easy, right? Either
Easy,
tabular
yes.
method or MATLAB, the easiest method. You can do it
Table.
in other methods, but it is time
What are
consuming.
you-
It takes too much time
No.
to calculate,
Thanks.
especially during your exam. You don't need to consume too much time for calculation of convolution. So you have to choose which method is the easiest method. For me, the tabular method is very easy. You write x of n vertically, horizontally, x of n values, sorry, h of n values horizontally, multiply, shift, multiply, then add vertically, you will get the output. So it is the easiest method. That's why I showed you. But there are other methods, graphical method, polynomial multiplication method. There are many methods to calculate convolution. Any other question?
Okay. Thanks.
Okay, so